everybody, Ms. Volcano here, and I'd like to walk you through this worksheet on isotopes, talk a little bit about isotopes, what they are, and how we can work with them. You guys are going to have to complete this worksheet as part of your classwork, so I'm going to give you some hints on how to do that. All right, so let's start off with what are isotopes. So isotopes are atoms of the same element. All right, they have the same atomic number, meaning the same number of protons, but different atomic mass. So you may see isotopes written something like this. So C-12, C-13, C-14. What does this mean? C we know is carbon, so that's the element carbon. -12 tells us that this carbon atom has an atomic mass of 12. C-13, it's still the same element. It's still the element carbon, but now we have a different atomic mass of 13. And C-14, again, we're dealing with the element carbon, and the atomic mass in this case is 14. So as you can see, the one element, carbon in this case, can have different values for its atomic mass, and that is because it can have different number of neutrons in its nucleus. Now, in this example, C12, C13, and C14, we are dealing with carbon. Since we're dealing with carbon, all these three isotopes must have the same atomic number. Okay, so that's really important. They have the same number of protons because it's carbon. Carbon is carbon. The number of protons is in carbon. You look it up on your periodic table. It is always going to be 6. It doesn't matter if it's carbon 12, carbon 13, carbon 14. The number of protons in that element, in those atoms, is always going to be 6. That is given by the atomic number. However, the number of neutrons in those atoms could vary, okay? And that is why when we go to the periodic table, we see this atomic mass that has these decimal points, okay? The atomic mass is basically an average of all the possible isotopes of carbon that we know of. And when you average them out, we have some isotopes that are more common than others, and you end up with this decimal. So going back to, let's see how we can work with this, and let's jump right in and do some of these examples. All right, so let me go to my Jamboard and jump right in and show you guys how to do this. So let's start off with this first one. Using a periodic table, it's asking you to answer these questions. So this diagram right here is representing the nucleus, the nuclei, plural, of atoms. So in this particular nucleus, it looks like we got 3 P's, meaning 3 protons. All right. And it looks like we got 1, 2, 3, 4 neutrons. All right. So I'm going to also put my charges because I know those, and I'm going to write 3 protons, 4 neutrons, like that. All right, so the first question is asking is, what is the element? Well, how do I know what the element is? I always look by looking at the protons, okay? So I'm looking for an element that has 3 protons. I'm going to go to my periodic table, and I'm looking, 3 protons means atomic number of 3. So here's my atomic number 1, 2, they go in order. 3 is lithium. Atomic number 3, 3 protons. Lithium is my element. So I'm going to go right here. Whoops, sorry, back to my Jamboard. And what is this element? It's lithium. And here's the symbol for lithium. Question, how many electrons does the neutral keyword right here, atom, have? Well, if it's neutral, I know that it's positive charges, which it has 3 positive charges, 3 protons, must be balanced by 3 negative charges, meaning that I have 3 electrons. So I gotta have 3 electrons for this in order for this atom to be neutral. Final question, what is the mass number? So a little bit of review here. How do we calculate mass number? Well, mass number is, whoops, sorry about that. Mass number, I know that I have to add my protons plus the number of neutrons. That gives me my mass number. How many protons do I have? 3. How many neutrons do I have? 4. And so my total mass number is 7. All right. Follow the same thing for the rest of the examples, which you have a few of. Let's move on. Let's see, what else did I want to do? I wanted to help you guys with number 2. So number 2 on your assignment looks like this. I'm gonna do question B as an example for you. So question is asking how many protons and neutrons are in the nucleus of each isotope. And my first isotope that I'm going to do right now is scandium 45, and I am told the atomic number is 21. So protons, well, protons I know are always given to me by the atomic number. I don't care what isotope I'm dealing with, whether it's scandium 45, scandium 44, scandium, whatever. If it's scandium, the atomic number of that element is going to give me my protons. So my protons are equal to the atomic number of 21. Neutrons, so looking at this isotope, I know that this number here is giving me the atomic mass, because that's how we write isotopes. So I know that number of protons plus number of neutrons are giving me my atomic mass, which in this case is 45. All right. Well, number of protons, I just said is 21. So 21 plus what number equals 45? And I can do that in my head or using my calculator, whichever way is easier for you, simply by subtracting 45 minus 21. So my answer is going to be 24 over here. 24 neutrons I need in order to get the element scandium with an atomic mass of 45, which is an isotope of scandium. So go ahead and using the same methodology, complete these examples. Question number 3, although electrons have mass, they are not considered in determining the mass number of an atom. Why is that? So we talked about that quite a bit in class. I'll let you guys review that and answer that question. Question number 4, hydrogen atom has 1 proton, 2 neutrons, and 0 electrons. Is this atom an ion? So going back to ions, which I made a video for, feel free to watch that. You should be able to, based on that video, based on the worksheet that you did on ions, you should be able to answer this question. Let's go to number 5. An atom, and I actually think I put this one on the Jamboard, so let's go right there. Okay, question number 5. An atom of sodium 23 with an atomic number of 11 has a positive charge of 1. Given this information, how many electrons does it have? How many protons and neutrons does this atom have? All right, so let's break this down. Let's break this down. So what am I told? I'm told sodium 23 is my atom. Okay, so what can I gather out of just this, from this information right here? Already I know that my atomic mass is 23. All right, just by the way this is written. I am also told that I got an atomic number of 11. So atomic number of 11. What does that tell me? Well, right away I know that that is also equal to my protons. So I can go ahead and fill this information right here. Finally, I'm told about this positive charge of +1. So let's see what we can do with this piece of information here. Atomic mass is 23. What do I know about that? Well, I know that atomic mass is equal to the number of protons plus the number of neutrons. But I already found my protons, 11. So why don't I just replace this P with the number 11, because I already found that. So if I got 23 equals to 11 plus some unknown number of neutrons here. Well, I can pretty easily do that math. 23 minus 11 equals 12. So I know that I got 12 neutrons. Finally, electrons. How am I going to find that? Well, I'm told this piece of information that I haven't really used yet, so let's use that. I'm told I got a positive charge of +1. So let's write out our charges for this element, okay? So protons, I know they are positive. So I got 11 protons right here. So let me do 11 pluses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is going back to the ions. If you need to review that, please go back to that worksheet and that video. Electrons, I know they are negative. And so how many electrons do I need to put so that I end up with an overall net charge of +1? Well, if I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, watch what happens. These 10 electrons perfectly balance out those 10 protons, and I end up with just this one charge of +1 left over. So that means I must have 10 electrons. The error that a lot of people will do here is that they will actually change the number of protons instead of changing the number of electrons. Remember, number of protons tell us what element it is. So if we're dealing with sodium, atomic number of 11, do not change that number. That number, if you're changing, let's say protons to atomic number of 10, you're no longer dealing with sodium. You're no longer dealing with sodium, atomic number of 11. If you change the protons to 10, now you're dealing with neon. It's not the same element. So please be really careful when dealing with this, that you don't change the protons and end up with a different element. All right, let's see if I had anything else. Okay, yeah, I wanted to run you through how to do some of these examples. So let's see how we would do, how we would write these. Are called nuclear symbols. They basically contain all kinds of information that is useful. A nuclear symbol example would be this helium right here. You can see it contains the mass number in the upper left-hand corner, lower left-hand corner, atomic number, and upper right-hand corner, the charge. Same thing over here with the sodium ion example. So let's do example number, let's do this one with 6. So atomic number 6. How do I know what that is? Let me just go to my periodic table and right away, atomic number 6, I'm going to look it up. Here it is, carbon, atomic number 6. So let me just write that right in here so I have an easier time doing that. Mass number or atomic mass of 12. Number of protons. Well, atomic number gives me number of protons always, so I know I got 6. Number of neutrons. Well, if I got my mass number minus my protons, that gives me my neutrons, right? So 12 minus 6 equals 6. I got 6 neutrons. Number of electrons, I am told I got 6. So the nuclear symbol for this is actually going to be really easy. It's going to be the letter C for carbon. So I got to write down the element symbol, C, mass number 6, atomic number 6, and charge. Well, what is my overall charge? So my overall charge is going to be my net charge. So if I got 6 protons, 6 electrons, they basically cancel each other out. They completely balance each other out. Do I have a net charge? No, I don't. So I just don't write anything. If I had a net charge like +1 or +2 or -1, then I would write it up here in the right-hand corner. All right, so go ahead and do the rest of this assignment. Good luck. I hope this was helpful, and I will see you guys in class.